Okay, first of all, this is the third time I have tried recording this video and things keep going wrong. I'm about to lose my mind. I hope I make it through this time. I hope your quarantines are going a little bit better than mine are right now. So this is 9-6. You're going to use quadratic equations to help you find key features of those equations. Remember to be taking notes, writing things down in a notebook or on sheets of paper, and then keeping them in a folder in your binder as you're going through. Okay? Don't just watch the videos, actually take notes. The key features that we're going to talk about, you learned back in 9-1, and we looked at them from graphs in 9-1. Now we're going to do the same key features, except we're going to figure out how to do them from the equations only without having to look at the graph. So the first couple are ones that we've already talked about what they are, but now we need to talk about how to find them from the equation instead of the graph. So one thing I would highly recommend that you do is you pause the video and get this copied down, and then you can follow along and listen with me of any added stuff that I tell you. So the first one is the y-intercept, which the y-intercept is located on the y-axis, and since it's on the y-axis, the x value in that case is 0. So to find your y-intercept, all you need to do is plug 0 in for x and then solve, and it will be really easy, and I'll show you in the first example how easy it's going to be. Your roots, which remember are the zeros or the x-intercepts, are located on the x-axis. Remember that there are going to be 2 of them in most of our cases, and actually in this lesson there will always be 2. You will find them by plugging 0 in for y, because if you're on the x-axis, then your y value is 0. But then once you've plugged it in for y, you have to solve either using your factoring or your quadratic formula that you learned in either 9-4 or 9-5. You get to decide which method you preferred, okay? So some of you really like factoring, you can factor. Some of you really like the quadratic formula, you can do that. Some of you don't care, maybe you want to do some of factoring and some of quadratic formula, it doesn't matter. You choose. Next is your vertex. Remember, the vertex is the coordinate point of the highest or lowest point on your graph. Your vertex has some x, y coordinate point. You need to be able to find both of these. The x value is found by taking the average of your roots. So back up here with your roots, your x-intercepts, your zeros. Whatever your roots are, let's say you get x equals 1 and x equals 5. The average is adding those together. 1 plus 5 is 6, and then dividing by 2. 6 divided by 2 is 3. That gives you the x value of your vertex. The y value is then found by taking that number and plugging that into your equation, in for x, everywhere you see an x, and solve for y. That gives you your x, y coordinate point for your vertex. The axis of symmetry is the vertical line that goes through the middle of your graph, goes through the middle of your parabola. It has an equation, x equals, and then the x value of your vertex. So whatever number you found back up here, it's just x equals that number. All right, now there are a couple new ones that we need to talk about. The first one is the direction of the graph. So when you have your parabola, oh, sorry, I lost my thing that I can write on my computer with. When you have your parabola, it can either look like a U or it can be an upside down U. This graph opens up because it goes up forever. This graph opens down because it goes down forever. From the equation, you can tell if it opens up or opens down based on the a value of your equation. Remember, in standard form, it is y equals ax squared plus bx plus c. So we're talking about that number in front of x squared. If it's positive, greater than 0, your graph is going to open up. It'll look like a U. If that a value, however, is negative, if it's less than 0, the same number, if it's negative, it's going to open your graph down. It'll look like an upside down U like we have over here. Your graph has either a maximum or a minimum. Remember, the maximum means the highest, and the minimum means the lowest. So if I look at this graph, There isn't a highest point because it goes up forever, but there is a minimum, there is a lowest. If your graph opens up, then it will have a minimum, and it is located at the y value of the vertex. This y value is the lowest that this graph goes. It doesn't go any lower. If your graph, however, opens down, if I look at this graph, it opens down, which means there is not a minimum. It goes down forever, but there is a maximum, and it is right here. So if your graph opens down, then there is a maximum at the y value of the vertex. So your maximum is whatever is this y value. Now we need to talk about domain and range. So remember that domain are your x's. So now I'm looking at this graph here on the left, and I ask you how far to the left it goes. Well, these arrows tell you it's going to go left forever. And then these arrows here on the right are going to tell you it's going to go right forever. So this graph goes from negative infinity to infinity. The graph on the right, if I look left, goes left forever. It goes right forever. So this graph also has a domain of negative infinity to infinity. And that is true for all of your graphs for your parabolas. Your domain is always going to be negative infinity less than x less than infinity. But your range is going to depend on your graph. If your graph opens up, so our graph looks something like this. For your range, we're talking about the y values. You always start with how far down to how far up does your graph go. Well, how far down your graph goes, it goes this farthest point down, which in this graph is the minimum. So it would start with the minimum less than or equal to y. And then we ask how far up does this graph go? Well, if it opens up, that means it goes up forever, so less than infinity. If, however, your graph opens down, your graph looks something more like this. Well, start with how far down does this graph go? This graph opens down, which means it goes down forever. Negative infinity less than y. Then we ask, how far up does it go? It goes up to this point, which is your maximum. So your range is either the minimum less than or equal to y less than infinity, or negative infinity less than y less than or equal to your maximum, depending on what you have. Okay? So we're going to look at some examples together so that you have an idea of how to do all of these things. So in our first equation, let's take y equals x squared minus 2x minus 15. Now the y-intercept is the easiest one. Remember, for the y-intercept, we just plug 0 in for both of your x's, or in for all of your x's. So I would do 0 squared minus 2 times 0 minus 15. 0 squared is 0, and negative 2 times 0 is 0. That leaves you with y equals 15, y equals negative 15. So your y-intercept is 0, negative 15. Here's the trick with this. Wherever your variables are, those terms are going to go away because they're zeros. So your y-intercept is always going to be 0, comma, the constant, in our case, negative 15. So you don't even have to do this portion. I expect that you should be able to tell me it's 0, comma, and then the constant. Now the roots are going to take a little bit more effort. Remember, roots, zeros, x-intercepts, they mean the same thing. So we start by plugging 0 in for y. So we have 0 equals x squared minus 2x minus 15. Now you can decide if you want to solve with the quadratic formula or with factoring. In this example, I'm going to go through factoring. In both cases, you have to be able to know what a, b, and c are. A is 1, b is negative 2, c is negative 15. With factoring, you start with multiplying a and c to get negative 15. Then you're going to use Desmos. You need two numbers that multiply to be that answer, and those same two numbers need to add to be b, which is negative 2. So we're going to type these two equations into Desmos. X times y equals negative 15, and x plus y equals negative 2. and I get -5 and +3. So what that means is I have 0 equals, my two numbers were -5 and +3, so my variable -5, and then my other one, my variable +3. Then you take these two numbers and divide by a. But in our case, a is 1, so dividing doesn't change anything. Next step would be take your first set of parentheses and set it equal to 0, and your second parenthesis and set it equal to 0. In this equation, I would add 5 to both sides, giving me x equals 5. In the second equation, I have +3, so I need to subtract 3 from both sides, giving me x equals -3. So your roots are 5, 0, and -3, 0. Those are your roots, or your x-intercepts, or your zeros. Solving by factoring. If you want to solve using the quadratic formula, you should get the same answers. I'll show you an example of that in the next one. Now for the vertex. We'll start with the x value. The x value is found by taking your two roots, 5 and -3, adding them up and dividing by 2. So we're going to take 5 and -3, we're going to add them and divide by 2. We can do that in Desmos. Just make sure you put parentheses, 5 plus -3, and then divide by 2, because otherwise it's going to not divide the whole thing by 2. We get 1. That is the x value. Now to find the y value, we need to take that answer and plug it into our equation in for x. So our equation was y equals x squared minus 2x minus 15. This is our x value of the vertex. We're going to plug that in for x everywhere we have an x. So y equals 1 squared minus 2 times 1 minus 15. Remember, when you square a number, put it in parentheses and then square it on the outside. I can go back to Desmos to do that. 1 squared minus 2 times 1 minus 15 to get -16. So my vertex is the x value comma the y value. 1, -16. The axis of symmetry. Remember, is the equation x equals, and then just the x value of the vertex, which for us, the x value was 1. So x equals 1 is our equation of our axis of symmetry. The direction of our graph, well, our equation, remember, was y equals x squared minus 2x minus 15. We can tell if it opens up or down based on the a value. Our a value is 1. That is positive, so it opens up. Does our graph have a maximum or a minimum, and then where? Well, since our graph opens up, it looks something like this. If it opens up, that means we have a minimum point. And where, remember, is the y value of your vertex. In our case, our y value is -16. Your domain, remember the domain is the easy one, is always -infinity less than x less than infinity. Your range, we start with how far down to how far up. If you have a minimum, you start with that value. So we're going to start with our -16, less than or equal to y. Less than how far up is going to go to infinity. If you had a maximum, it would be -infinity until your maximum.